Greetings, welcome to AP Chemistry course. In today's lesson I'm going to talk about combined gas law. Alright, so in today's lesson I'm going to talk about combined law, or combined gas law, and it simply talks about three different rules. The first rule that it contains is Boyle's law. So we have Boyle's law, and then we have Charles' law, and then we have Lusak's law. So, what are we talking about? Let's imagine we have a container, alright? So it's like a balloon, and we just we just pressurize it, we squeeze it, or for example we have a piston, we're squeezing it. So we're increasing pressure, alright? So volume is decreasing. And let's say then we're trying to change the temperature. For example, let's turn, for example, we're cooling it and we're decreasing the temperature to 0 Celsius and we're increasing the pressure. So we're playing with different or major units. We're playing with temperature, playing with pressure and volume. So can we just use a certain gas law to apply calculations? Well, certainly not, because applying one type or one rule won't help us, because as you can notice we're dealing with three different units and all the gas laws contain 2 units. Alright, so now we're going to start with the combined gas law that talks about the mixture between the gas laws, which are the mixture between Charles, Boyle's and Lusak's law. So the new formula that is going to be drawn or written as P1 times V1 over T1. So pressure times volume over temperature equals pressure times volume over temperature, the second. Alright, so let's solve a question, because as an introduction we need to just solve one question. Alright, so the question mentions a 70-liter container is filled with air at sea level. We have 1 atm pressure and 35 Celsius as temperature. Later on, the temperature dropped to 1 Celsius and the pressure to 12 atm. Of course, the pressure didn't drop. Alright, it's increased. Alright, it's increased. So the temperature dropped to 1 Celsius and the pressure went to 12 atm. What will the new volume be? So the unknown here is the volume. The givens are 70 liters in a container with a pressure of 1 atm, temperature of 35 Celsius, then temperature dropped to 1 Celsius, increased to 12 atm. So what will the new volume be? That means volume is unknown, as they ask what will the new volume be. Let's start. So first things first, as a law or as a small rule that I tell most people, always write down what you have or what's given, especially in chemistry. So first things first, a 70 liter. 70 liters is the volume, so that means we have V1 equals to 70 liters. Container filled with air at 1 atm, so we have the pressure. The pressure is going to be 1 atm is the unit, and we're going to have 35 Celsius as the temperature. Alright. Then we're going to go there. We have second given temperature going to be 1 degree Celsius. We're going to go with the pressure that is given, going to be 12 atm. So the second pressure is going to be 12 atm. And the last thing is volume. The second volume is unknown, putting a question mark instead. Alright, great. So, from what we are given right now, we can conclude something. We have all of the givens, but for the temperature, we all know that for temperature that we must have the unit as Kelvin, because we know Celsius is no good for chemistry. So, for the calculations, converting 35 Celsius degree into Kelvin, how can we do that? You can watch my videos about gases, and it mentions the formula. And if you don't want to go back and wait and watch the video, you can just watch it right now. So the formula mentions that to convert temperature to Kelvin, we need to do number 1, writing 273. You can put 0.15 plus the Celsius temperature to get the Kelvin temperature. So the given here is going to be 35 Celsius degree, and we're going to put here 35, and just to not to waste time calculating anything, we're just going to use a calculator. 273.15 plus or added to 35, and that's going to equal to 308.15. So the temperature here is 308.15. 308.15 Kelvin. What about 1 Celsius? Of course, we're just going to put 1 right over here, and what are we going to get is another digit, which is going to be 274.15 Kelvin. Alright, great, we got the givens. Let's start solving. So, we got the formula right over here, and I'm going to start switching units according to what's given. So, number 1, P1. At P1 we started with 1 ATM, writing down as 1 ATM multiplied by V1, which is going to be 70 liters. Great. Then we write down the other given, which is the temperature, 308.15 Kelvin. Alright, that's great. Now we're putting everything given, but do you think that's an easy way to solve questions? Well, of course it's easy to solve in that way, but let's make an easier way. So you can keep with the digits given, but in order to solve a question like that, not to make any mistakes, you start solving without digits. You directly switch everything and you start. What is the unknown? V2. How can we leave it in one side of the equation? So, in order to do that, we multiply T2 on both sides. So when we do that, we're going to end up with T2 multiplied by P1 multiplied by V1 over T1. Great. That equals to P2 times V2. In order to take or to keep V2 on one side of the equation, we write P2 and we're going to divide it here, so it's going to be multiplied by the T1. So this cancels this out, and we're left with the new formula as this. V2. So T2 times P1 times V1 over T1 times P2 is the new formula that can be used to solve the question. Let's start solving according to this new formula that we just made. So let's start. So T2, which is given as 274.15 Kelvin. So we write 274.15 kelvins multiplied by the pressure, which is going to be 1 ATM. Now I put a small dash under the units. V1 is going to be 70 liters. 70 liters. Over all of that, we're going to have T1, which is going to be 308.15 kelvins, another dash, multiplied by P2, which is given as 12 ATM. And that all equals to V2. Great! Doesn't that look easier to solve? Yeah, of course it does. So, let's solve using the new way. So, Kelvin goes with Kelvin, ATM goes with ATM, and we're left with the unit liters. Liters is always for volume, so we got the we got the unit. That means we're doing everything right. So, let's do the math right now. So, we take the calculator and we start solving. So 274.15 multiplied by 1 multiplied by 70 divided by 308. So 308.15 multiplied by 12. So that will all equal to 5.18. So V2 will equal to 5.18 liters. So this is our final answer, and we got the volume. Well, that's great. Well, because in the past videos we talked about the gas laws, and we just can't got we can get only one unknown, or we can get a 1 unit out of 2 units given. So we're going to have, for example, pressure and we're going to have pressure and temperature, and we're going to get the pressure out or temperature out. So we have 1 unit to be given from out of 2. But here we can see that we have 3 units, and we can get 1 answer from that. So that's really great. So it makes it really simple for us instead of having a chaos of trying to figure out what's the temperature or what's the volume in those 3 digits. We have the combined gas law that just fixes up all of the digits together, going with P1 times V1 over T1 equals P2 times V2 over T2. So a quick recap. To summarize everything up, combined gas law is a law that combines 3 different laws: Lusak's law, Charles' law, and Boyle's law. And in total, we're going to take an idea of a change in temperature and pressure of volume at the same time, and it's going to be easy for us to calculate the unknown digits or the ungiven value. So in that way, it will make our life simple. So this is all about our lesson for today, and I hope it was useful. Have a nice day, and don't forget to check out the playlist gases. So this is all about our lesson for today, and I hope it is useful. Goodbye.